It is my great pleasure to introduce you to our next speaker, Amy Delves. Now, I have known Amy, gosh, when did we meet? Maybe 24?
DevWorld?
No, was it DevWorld or was it WWDC? I remember we were at like a Cocoa, the quiz night in San Francisco. Anyway, we go back a long time.
Skips to one.
Yeah.
I'm feeling old.
I only really see Amy at events at DevWorld or the occasional WWDC, but it has been just a joy to watch Amy's journey over that time. And her journey brings us to this place. I believe Amy's been working on a new app, a health-related app that we're going to hear about today. So please join me in welcoming Amy to the stage.
It's good to be back, even though, I live, 3 Ks that way. This is the home conference, so every year it is good to be part of the community here. Tony did a really good job of mentioning all the benefits of the community. Just want to add to that, hey, it's great to see all the old faces, all of the new faces, and yeah, just meet heaps of people, chat about what they're building, what they're doing, and get a lot out of your time here. For those that don't know me, I am Amy. My pronouns are she, her, and I'm going to talk to you about a conversation with your health data. So this talk, 72 slides, so hopefully I'm going to get through most of it, but yeah. It's going to start off with a bit of an introduction and a preamble. Then we're going to look at the foundation model side of it. We're going to look at HealthKit, and we're going to sort of progressively construct parts of an app to see how it all can fit together. Going to look at a more complex example if there's a bit of time, and also some of the pitfalls around how it all fits together. So, first thing. Any conversation about health must be inclusive of trans rights, which is, you would think, oh yeah, this is something fundamental, but no, particularly with large amounts of health data and people wanting to exclude parts of health data, then this is something that we need saying. What is going to be built? So, as well as my regular day job, which is doing some health techie stuff, I'm doing stuff personally in the evenings and on weekends to build out what is being called HealthKit. So anyone that has done stuff with HealthKit knows HealthKit from there. If you've been around computers for a while or even telephone networks, you would know TTY is for teletype, so combine them together, you get HealthKit. This is a conversational and accessible way of accessing your health data. It's also just a lot of fun to be playing around with this and trying it all out. Ethics in AI usage, which is the hot topic at the moment. Pretty much, how do you use all of this new stuff, all of this data, and do it in an ethical way? I'm not really going to touch on it too much at the moment, but it does need to be said that with all of the AI stuff, try to avoid doing a diagnosis. That is pretty much not going to get you in anyone's good books if you're diagnosing health data using AI. It's pretty much not only going to technically fail, it's ethically not the best stuff. So doctors will always have a place, health professionals will always have a place. So, yeah, just remember that. Cool. Now let's start by answering a question. This is getting to the point of, okay, how do we make health data accessible in a conversational way. So the question we're going to try and ask and build out as an example is, what is my heart rate? This is a fairly simple question where it is asking for something at a moment in time, or you can just ignore time and give the most recent bit of information. Building this out needs some work with foundation models as well as some work with HealthKit in order to combine everything together. First thing we'll do is look at defining the session. So if you played around with foundation models, then the session is your access into all of the LLM, all of the generative AI, and it's going to look something like this. So calling this initializer will give you an instance of your session. You provide it with the model. Default will be the standard Apple supplied model. You can also build your own, but that's a whole heap of complexity. Haven't quite looked at that yet. It would be kind of fun to build a model that works on device, specifically trained around health data. That'll be pretty cool. One day I might get to do it. But as well as that, you can look at providing a whole heap of tools to it. Tools are what allow you to access extra information either via different frameworks or API calls or whatever you want, and also provide a whole heap of instructions. So let's break this down a bit and look at the instructions. Instructions are the sort of overall encompassing parameters for the LLM. Don't like calling it AI because it's not really that. So I'll use LLM, I'll use generative AI to sort of show that it's something that's taking stuff and producing an output in a text form. With the instructions, this is stuff like the tone of voice of your output, anything that will relate to the entirety of a session rather than a single prompt. I'll get to what a prompt is in a bit. When you construct it, Apple gives you a very nice result builder, which is the instruction builder, and you can use it to take in things like all of your different sentences there. You can do conditional logic in it as well if you wanted, or you can even sort of extract previous outputs. I'll get to that closer to the end, but using the instruction builder is going to be one of the best options because it allows you to just spell everything out. You've got the link to Apple's documentation there, which is pretty good. Just as an aside, I did see someone released a thing called Sosumi.ai. Absolutely amazing in that it's taking Apple's documentation as a markdown format and making it available in an AI agentic way, which is a MCP service. That's pretty cool. The prompt. So as well as all of your instructions, which are for the entirety of your session, a prompt is for a particular interaction, so a single interaction with your health data, not the health data, with your language model session. A prompt will look like this. So you can do things, again, it's a prompt builder. You can ask just a simple text-based input from your user, from your UI, but quite often you want to extend upon that a little bit in order to provide more context and interaction around what that input is. So for my cases, I look at stuff like what are the health terms used, what any well-being terms used like state of mind and stuff like that, as well as any date phrases like today, yesterday, a week ago, in the last month, all of that stuff extracted out so that the language session itself has a better way of identifying it in the actual usage. Then always sort of answer the question from the user. And hopefully it's a question that the user has put in there. Now, because stuff like your health data, any API interactions, all of that stuff is sort of not part of the initial data set, you need to use what's called a tool in order to get all of that information into foundation models. So a tool is one part of what's called a model context provider. Apple doesn't directly expose MCP as a concept in its language in foundation models, but we do get what's called a tool in order to interact with it. So, yeah, this is what it's going to look like. Link there to some documentation, but the tool is defined as your own type. The important bits are providing a name, which will be the function name you will use to identify it. It'll be a description as well, so that the model knows what interactions are provided. Then you look at stuff like the arguments, which are the bits of data that get extracted from your prompt and passed into the tool. As well as that, you then go through all of your, you've got your call function in there. The call function is what you use to provide the business logic. In this case, it is predominantly interactions with HealthKit are going to be in there. Let's take a look at the arguments. So in the case of what is your health data, what is your health rate, what is your heart rate? Little bit of anxiety getting in and causing me to slip up my words a bit. What is your heart rate? Looking at that, the argument we would want to extract is heart rate. That's the bit of data you want to identify from it and gets passed in. How does that work? Well, you define a type in your tool called arguments, and you annotate it with the generable keyword or the macro, and that means that this particular type can be exposed to the language model and understandable by everything going on. So you can do stuff like extracting the dates. You can look at extracting any health types like heart rate in there as well. And also, in my case, I sneak in a summary identifier, which is just a unique ID to allow me to store extra information that's not part of the response. This needs a bit of breaking apart because there are a few different complex ideas here. The first of them is the generable macro. So generable is used in a few different ways. First is in allowing your arguments to be converted into a type understandable by the model. Generable, to an extent, is very similar to codable in that it is taking your type and putting it into a JSON or other format that then gets interpreted by the model. So let's take a look. Here we're just again setting out the arguments and marking it all as generable. With all of your different arguments there, we are using a thing called a guide, which is a way of saying to the model, these particular variables should be filled out in this way. So if you encounter something that looks like a bit of health data, assign it to this particular variable. If it looks like a date or a phrase relative to time, assign it here. So what is the guide? The guide predominantly is that descriptive phrase that assists the model in identifying what data belongs to a particular variable. Here are some examples along with the documentation link. The main one is just taking it and storing it as a string, which you can do fairly easily, but you can also constrain the particular values that get assigned to it using the any of property there. So you can go any of, say, what is it? Cycling, running, swimming, standard triathlon stuff, which could be fun, and storing it there. You can also constrain like a numerical value based on the range, and in this case, something between 1 and 10 could be an option for it. One of the other really nice bits is you can use your own custom types there. So if you've got an enum of all of the different values, you can have your language model assign those specific types and have it there to use. The type itself needs to be marked as generable. Generable really is this sort of all-purpose, make this type available to the language model macro, and it will try and pick out all of these particular phrases and create instances of the required type. Prompt representable. So this is taking a jump into the output of your tool. Now the tool has a requirement for a function called call. Call gets passed in some arguments, and then the return type of that particular function is some prompt representable. Prompt representable, if you think about it in the sense of MCP, so Model Context Protocol, Model Context Protocol, then it is a JSON response. And early iterations of this actually sort of allowed you to just return a JSON string, but it's now a bit more type constrained, which is a lot nicer. So two common options is either return a string, or you return a type that is marked with @generable. Looking at the string response, could be something like, you did 3 workouts today, which is, yay, that would actually be pretty good for most people. You could then look at a generable response, which is a bit more complex. Don't try to read all of that. That is specific to what I'm building out, but it is an example in that you can have this complex type as what you get returned. I'll get into some of the pitfalls around it later, but for the most part, you mark a type as generable, and then you can use it as what gets returned from the call argument. So that's a quick overview of foundation models. I know a few other speakers are going to be talking about it later on, so they might not go into a bit more depth, but that is some of it. Next thing is interacting with HealthKit. So HealthKit has been around for a long, long time, since 2008, when the, was it 2008? iOS 8, 2014. Yes. Yes. Anxiety, I get things confused. Okay, has been around since iOS 8, which came out in 2014, and that corresponded with the Apple Watch coming out as well. So if you think about it, for a lot of people, they've probably had all of their health data being collected since 2014. So over 10 years, over 11 years in some cases, and now have this huge complex set of data. That is what HealthKit is. It is also health data, which means you need to worry about permissions. You don't want apps getting access to absolutely everything and then farming it off to their own AI or whatever. You don't want them doing weird analytics and selling it to insurance companies. That's just not going to be good for anyone. So permissions, when you want access to anything in HealthKit, you need to request the permissions for it. Let's take a look. First thing you need to think through is this authorization request status. So when you say to HealthKit, can I please have permission to all of these types? It will give you, as a response, one of these values. So it'll go, do I know about it? Which is the 0th there, being unknown. It's got, should I request, as in, do I need to prompt the user to present the authorization form going, please grant this app access to the data, or it will go, I've shown this form before. Now, anyone that thinks through permissions would often want to go, okay, is this granted or not? And that's not what HealthKit gives us. It gives us an idea of, have we prompted the user for permission? I will get into why that's a concern you need to worry about in a bit, but let's look at how you actually show this permission to the user, which is what happens when you prompt the user. These days, most people are building apps in SwiftUI, and there is also a framework called HealthKit UI, which gives you this particular function on Vue, being a request for access to your health data. So this will show up that permission sheet and give you what you want. You provide it with your instance of HK store, and then you say, I want to share, which is I want to write into HealthKit all of these particular bits of information, and then also read, which is I would like to get access to all of this information, and then also a trigger, which is a binding to a Boolean value, being once the user has done something and your business logic triggers this bool to be true, show this particular view. It will then go and present the prompt. In its completion closure there, you will go, okay, now that all of this has happened, I want to then update all of my internal logic based on the new status there, which is pretty cool. So you've done the permission dance. Now you want to check that you've got access to the data. And this is where it gets a bit tricky, because presenting, like being prompted for access, does not mean that the particular data itself is available. So what you need to do is go, okay, for the type of information I'm interested in, do I then have all of this data? Do I need to prompt the user for permissions? If not, then do a test query. That test query can be, is there a single point of data for this particular value in the past week? If there is, then assume it's got all of the access. If it's not, then you have to treat it as unknown, as in, well, we don't know, maybe this data's there, maybe it's not, maybe we don't have access, and go from there. And that's really this no data or no access, which is a bit fuzzy. So you don't know whether not getting a response means no data or no access. You just need to keep it in mind and appropriately prompt the user as a result. Whew, that was a mouthful. HK object type, and this is getting into the depths of HealthKit a lot, being when you're dealing with bits of information in HealthKit, there are a lot of different types you can be dealing with. The main ones are going to be your category type, which is stuff like your sleep data. Then also your quantity type, which is going to be pretty much everything else that isn't a specific thing. You've also got workout types, which is specific for returning workout objects. Reason this is important is when dealing with things called predicates. If you've been around iOS development circles for a while, you will know what NS predicate is, which is a way of constructing a query to search for data. NS predicates can get pretty complex in that they are like database queries. I'm going to try and avoid using database for HealthKit itself because it's a bit more than that and it's a bit fuzzy as to where the definition is. But with querying HealthKit, you will need to construct multiple predicates. The first predicate you usually want to deal with is your start and end date. So you want to say, please give me samples between all of this. And then use that predicate to get specific typed examples. So your quantity sample in the case of a heart rate value, which you can use there. After that, you want to look at sort descriptors. Again, old Objective-C is NS sort descriptor. All HealthKit is still very much in the land of Objective-C, and I can see Tim celebrating with that one. Yep, a sort descriptor is a way of saying sort based on this particular property or closure or whatever you're dealing with, and do it in the sense of going forward or going backwards from that value. In this case, if you want to get, say, the most recent value, you would look at the end date for the sample. That will give you, and then sort it going forward. Doing that will give you the most recent value as your first value. Query descriptor. So this is another type that you use in order to combine everything in order to run the query itself. So it is a description of the query descriptor. This is what it looks like. Here you've got all of your predicates that you're wanting to run. You've got all of your sort descriptors, and you've also got a limit. So if you only want, say, 5 values or 1 value or 10 values or every value, you set the limit appropriately. In order to run the descriptor, you've got a function on the descriptor which will return the result. Because of the magic of Swift and Objective-C bridging, you automatically get a Swift concurrency value there. Samples. So mentioned before that quantity and category and workout are some of the typical types of data you will be dealing with. They have corresponding samples. Here you've got a sample which is your base type. It is defined in Objective-C, so it is an NS object, and it will define what the type of data is. It will also define what the start and the end dates are. You've then got your quantity sample, which again is going to be your actual quantity value, so your HK quantity itself. This is more than just a double in that it is a actual type, and you've still got your type there. It is an extension on your on HK sample. Category sample again is going to be the same, but for a category such as sleep. Here you've got start date, end date, which are there from your interaction with HK sample, but you've also got the category type, which will say it is for sleep category, and the value itself is an integer. So the reason why this is important is category samples are typically time-based, so you know from start to end, this particular category of event happened, which might be something like your deep sleep, your REM sleep, whatever, will be covered there. Cool. I've sped up a little bit because 5 minutes, and I'm going to assume everyone has questions. The tool implementation is going to be something like this. So here we are getting your quantity samples. We are then looking at the unit. So your unit is a value such as kilometers per hour, meters. It is something like counts or occurrence per minute and stuff like that. In the case of a heart rate, we refer to it as beats per minute. The framework itself will use counts per minute. And here we are just going, okay, for my quantity, give me the double value, so the numerical value based on this unit. Reason we want it based on a unit is because it will then do any internal conversions from how it is stored to how you want to represent it to the user. Then for a basic situation, we are going, let's just return this as a string. String is super simple in that the LLM will be able to identify it and use it as part of its response. Tying all of this together is going to give you something like this. You need to create the session first up. I'm using some helper functions that I've defined here, but it's similar to what I showed before, where you are providing some instructions and some tool instances to the framework in order to create a session. You're also providing a prompt. Here I've just been super simple and gone input straight into the prompt. We all know the dangers of user input and generative AI. It's not going to be too good, but here we are. And then getting the response, you can then, the response is a type, but its string output will be there in the content, and you can put it there. Cool, awesome. Bonus round. This is where it starts to get a bit fun. Going, what is my heart rate is good for your most current value, but what happens if you want to know what was my maximum heart rate yesterday? This is a lot more complex and a lot more fun because there are a few different things we need to understand as far as how to interpret this and how to translate it to a query in HealthKit. Yesterday, LLMs don't understand time well, so they will not be able to automatically get a phrase like yesterday and give you a date object from it. Instead, you need to do something as scary as this, which is you've defined your own type with a whole heap of terms, you mark it as generable, and you hope that what your actual LLM identifies is going to match up to this. As we all know, time is completely and utterly made up and is a relative idea. So we want to then provide a reference date, provide a calendar and go, okay, based on this, what is our actual date range that we can use in everything going on? Maximum values. So in all of our data, we then need to go through it and give ourselves the maximum value. It's not straightforward because different quantities get identified differently. So some quantities you might need to get the discrete sum, some you might need to treat average, some you might want to look at duration, which is all well and good. Heart rate, again, we've covered all of that. Then here all ends up being a bunch of samples, which is pretty cool. Skipping over it, fun stuff. Okay, string versus array versus generable. This is all going to be very contextual as to what you want to return as the prompt representable value. For a lot of my stuff, generable ends up being what I want because I want to return maximum, minimum, average, a whole heap of data. And yep, building out a complete response. So keep in mind how everything fits together as a whole in the context of what you're building. Errors. So errors are going to be something you want to understand and know because it's going to get super, super tricky, particularly when you're dealing with health data. You tend to want a lot of it, and that means you will get to the limit of your query tokens very, very quickly, which means you need to do fun stuff with the context window size. And here, one approach that I'll just gloss over because it's important is you will end up going through all of, you want to then take the output from your previous session, modify it, condense it somehow, stick it into the instructions, create a new session from that, ask the same question, return the response. That's fun, but it works for a lot of cases. Don't go crazy with the arguments because LLMs don't like it and can't sort of deal with it too well. So, yep, that is it. Hopefully just within time and not destroying the schedule. So, any questions, or is it a find me during lunch break?
I think we can squeeze in one question. Who's got the best question in the room? Yes.
Hey, Amy. How do you tweak the description in the guide to work better?
Trial and error. Okay, so the TLDR of how you do prompt engineering is you read a lot of other people's attempts at how they solve it, and you throw it all out because it's always super contextual.
Yeah.
There is a really, really good dub video on prompt engineering from this year, so 2025, that covers a lot of it, but it's, again, super high level. What you want to do is use the playground macro. Playground macro will allow you to pretty much put some code there and run it, and that way you will be able to tweak your inputs, your outputs, your instructions, your prompts, your guides, everything, and just iterate it over it that way. Unfortunately, can't be unit tested because that's not the nature of LLMs. Yeah, but really good question. Any others? I've got my head completely in this stuff, so find me during the break and pick it. Yep, here to help people out. Thank you.
Please, big hand for Amy.